You know, it was interesting yesterday on the bus trip, we were having a conversation about kind of talking with some folks about leading into this work. And one way I put it that has been an interesting way for me to think about it, you know, for Virginia, we do allow a lot of wrap in our asphalt mixtures. We allow 30%, up to 30% in our surface and 35% in our base, which is on you know, it's up there compared to the, I guess, the national picture. In a lot of our urban areas, we do a lot of milling and overlay work. Well, if you're allowing 30 or 35% to go back in, you're accumulating 65 or 70%. What do we do with that other 65 or 70%? That's what I'm talking about today. So some positive experiences with cold central plant recycling from our perspective. Cold central plant recycling, the components, and this is where I start to deviate a little bit, I think, from maybe what some other folks have heard. The components here that I like to look at it are milled or stockpiled wrap. I think most people have experience with taking millings from a project and putting them directly back maybe into a project. CCPR can also be used by taking existing wrap stockpiles that came from who knows where else, someplace else, and then putting back to a different project. So a little different way to think about it. So you've got this wrap material and then a recycling agent and maybe a chemical additive to go along with it. Most of our experience has been on the foamed asphalt side, but there are successful experiences with asphalt emulsion, emulsified asphalt, and then also adding chemical additives, lime and cement to that. Cold central plant recycling from the barn that we've all got a copy of now says that somewhere between 2 and 6 inches thick is a good layer thickness for CCPR. But the big benefit to CCPR is that we can make multiple layers. So we can make a pretty thick pavement structure using this recycled material by putting down more than one lift of this 2 to 6 inches. So it gives us an opportunity, I think, to think outside the box with this process. So why has this become such an important thing for us in Virginia? It's because we have wrap, and we have gobs of wrap. This is an example of a stockpile near the Dulles Airport area. The pile in the foreground to the right of the picture is about a 70,000 ton stockpile. The pile in the back is about a 100,000 ton stockpile. This particular contractor is located close to Dulles Airport, about 2 or 3 miles as the crow flies. And they actually had to strike off the top of their stockpile because they were exceeding the height of the control tower at Dulles. So they're out of room. There are other contractors in the more urbanized areas around Virginia that are renting land to store their wrap on. So some of the work that we've done and some of the information that we've gotten from our partners in the asphalt industry are telling us that we've got more than, or that Virginia has more than about 10 million tons of wrap stockpiled around the state. Now, one of the questions we had yesterday, thanks for leading it into today, Virginia, the agency does not maintain ownership of the wrap once it's milled. The contractor maintains the ownership of that. So the contractor is paying to haul that material around and to store it. So 10 million tons of wrap stockpiled around the state, and it's mainly concentrated in our urban areas towards the north and around Washington, D.C., the eastern side of the state coming down through Richmond and Fredericksburg, and then east towards the Hampton Roads region, where we do most of our mill and overlay work. So if I've got 10 million tons of wrap, what can I do with it? If I were to run that through a CCPR process, a 12-foot lane, 6 inches thick, I could pave from my office to Las Vegas and back with 10 million tons. So when you put it in that perspective, there's a lot that we could be doing with this process, a lot we could be doing with this product that we just aren't doing yet. We should be doing more with it. One of the things that I've asked is the folks from Napa, they go through and do their, material recycling, with their annual report of recycled materials. I've asked them to start including estimates of stockpiled wrap for each state, and I think they started doing that last year, if I remember correctly. So it'd be interesting to see what other states look like in terms of stockpiled material. From some of the states that I've talked to, we do not have the most. Here's a photograph of a typical CCPR plant, if you haven't seen this. This was a photograph taken from our ID1 project that was built in 2011. In this case, the interstate was actually just kind of over this little ridge line right here, so it was very close to the project. For this work, material was brought while the FDR process was being done underneath, and then this material was taken straight back to the project. In terms of the components that we see here, this is where all the mixing work happens. There's the vertical cement silo and the 2 horizontal silos in the background. Back here, one's a water tank and one's a heated asphalt tank. So in this case, we're using foamed asphalt and cement on the project. The material here, you can see, was discharged into trucks and then it's taken straight to the project into the paver hopper. So I'll talk a little bit about some of our experiences with CCPR. Two things I want to talk about were our projects that have been constructed and then one that we've got that's ongoing. Buzz touched a little bit on some of the work that we sponsored, the NCAT test track. I'll dig a little more into that and summarize real quick the 81 projects. I hope most folks have heard about that, but in case you haven't, there's a little info on it. So again, in 2011, we constructed this project on I-81. We were having a lot of issues with rapid deterioration of the asphalt mixture over top. Most of our interstate system consists of 10 to 12 inches of asphalt over 8 to 10 inches of compacted aggregate over top of subgrade. When this section of I-81 was built in the mid-1960s, early 1960s, mid-1960s, they brought in a lot of fine material to do the grading work before the aggregate base went on. A lot of that fine material happened to have a high clay content. I went out with the district in about 2008 or 2007, and we were doing some boring work, drilling, not actually like really boring work. We were doing boring work, and the material that we pulled up looked like silly putty. That's how, it was really high plasticity clay. It was very wet. There were no drainage feature, subsurface drainage features through here. And so that material over time was just not able to support the loading on the roadway. So the district folks were actually going back through and doing a rehabilitation option on this section of roadway about every 18 months. And in that 18-month process, they were going through and patching, and they were going through and documenting the cracks, and then having to come back and do a mill and overlay. So it was failing rapidly. So really, we asked for help from the industry, and the folks from Mike Marshall, some of the folks from Working came in and talked to us about what we could do, and really we were like, well, it couldn't be any worse than what we've got now, so let's think outside the box. And that's really how this whole concept came here for our first recycling project to be on a high volume interstate system. So right now, this section of I-81 carries about 24,000 vehicles a day with about 29% trucks. Our typical easel value on this section of roadway is 1.05 if you average all the trucks together. So we're carrying close to 7,000 easels a day in terms of the trucks on this. It's about 6,900 trucks per day. In the summer of 2017, this project was built again in 2011, and I'm going back trying to do about every year, going back and doing some testing on it. So we're having ride quality and rut testing done on it and FWD testing. In terms of this past summer, it had carried about 13 million easels with an IRI of about 44 inches per mile and about 1/10 of an inch of rutting. Fantastic performance, but really almost unchanged since it was constructed. So we've been really pleasantly surprised. We're not quite sure what we would have gotten out of it, but we've gotten good performance out of it. I haven't analyzed the last round of FWD testing, so I don't have any of that to present, but I have it sitting on my computer, and I don't know if I'll do it on the flight back or not. I probably should have mentioned the pavement design before I got into the details, but the pavement design, the first part of the project consisted of a 4-inch asphalt overlay over top of 6 inches of CCPR. The way this road was constructed, the very first step was 11-inch pre-mill, so almost all the asphalt layers were milled off. That material was stockpiled off to the site near the CCPR plant. A reclaimer was brought in, and they reclaimed a foot thick. And so it grabbed the bottom part of the asphalt layers, all the aggregate layers, and the top part of the subgrade. And that was stabilized with the cal cement product, so it's a combination of cement and lime kiln dust. As that process was going on, the CCPR material was being produced. After the FDR finished, we let it sit for maybe 4 or 5 hours, and then the CCPR was placed back on top. Through that process, we were really the first 2 steps, we manipulated almost 2 feet of material right off the bat. And the way we had this project set up is the contractor had access to the particular lane for a 5-day lane closure. So we ran traffic in one lane. They had a 5-day lane closure, and they did this process in pieces going down the road. So the first 3 or 4 days was a 2,000-foot segment where they milled FDR and CCPR, and the first lift of asphalt went back on top. And they went down the road in pieces like that in the right lane. And it took them maybe about 5 weeks to do a little over 3.5 miles going through that process. So the next project I want to talk about is the work we've done there at NCAT. We sponsor 3 test sections down there. And on the test track, the sections are labeled, there's a north and a south tangent section, and then each section is just labeled sequentially along there. So the 3 sections that we sponsor were N3 and N4, and then also S12. So 2 sections on the north tangent, 1 section on the south tangent. The NCAT track, the way they operate their system down there, they run on a 3-year test cycle, 2 years of trucking, and then 1 year of kind of data reduction, and then they work on the reconstructing the lanes. We sponsored these 3 sections in 2012, so they ran for 2012 to 2014. There was a year off, and then we sponsored them again, and they're just wrapping up now. I think the trucking will actually wrap up either the end of this month or beginning of November. We are looking to sponsor 2 more of these sections that I'll talk a little bit about for the 3rd test cycle. In terms of our sections that we tested or had constructed down there, we were really looking to mimic the ID1 project and then throw in a little variation on what we might expect to see on future projects. Again, we were kind of green in terms of our experience with this, so I probably would have done a few things differently knowing what I know now, but this is what we ended up with. So N3 and N4 were really comparisons, the same material underneath, and then look at the 2 different asphalt overlay thicknesses to see if there was any performance difference with that either extra material or having less material, depending on how you looked at it. And then N4 and S12, the comparison there is looking at the presence of the FDR layer beneath. And I put an FDR with an asterisk there because I guess really what we did was more of a soil or a cement stabilization project. Technically, FDR by definition has RAP involved with it. And actually what they did on the NCAT track was they milled off all the existing asphalt, and then we brought the reclaimer in to reclaim the existing aggregate on top of the subgrade. I guess I could call it FDR and remove the asterisk if I had some RAP in my pocket and threw it out on the road, but I forgot to do that. So I'll call it FDR with an asterisk. So we followed our FDR spec. We used the FDR equipment, but it didn't have the RAP in it. It was just the aggregate and the subgrade. So again, that material was that process happened back in 2012. So between 2012 and 2014, they ran 10 million easels on it. They have run about 8.9 or 9 million easels on the 2nd cycle, so it'll receive another 10 million easels here by the end of this test section. So we'll be up to 20 million easels by that point. I've been really fortunate for this project with the work at NCAT, getting to work a lot with folks like Buzz and Dave Tim, and I have learned a tremendous amount from those folks. So a lot of this information that I've got in here comes straight from Dave. And so Dave took some photos. This was back in September of the 3 test sections. And as you can see, just look at the surface, all 3 test sections look really good. And so they probably had about 18 million easels on it or so by this point. One thing that I do want to point out is this area right in here for the section S12. They had a rough patch in here going the transition from section S11 into S12. All the measurements that we've got are taken from in this area. But when they do the roughness testing, they count the whole, these are all 200-foot test sections, but this 50-foot section inside that kind of white square, if you can see that, that's where all the instrumentation is. That's where most of the test measurements are being collected. So that patch has nothing to do with the data except for the roughness value. So I'll show you the difference, what happened there. But anyway, it was a construction issue they had, and so they took care of this test round. So it looks like something's going on, but it's nothing to do with the material underneath. This slide, hopefully everybody can see all this. Looking at rut depth for these sections, we're up to about maybe 3/10 of an inch of rutting now, at close to 20 million easels. The values on this side up to about 1/4 of an inch are the first test track that's highlighted by this arrow, and this is the second 3-year test study, and here's the break in between the test studies. So one is 2012 to 2014, 2015 is the break, and then 2016 and 17 is this piece over here. The black line moving up is just the easel value. So the easel value goes to the column on the axis there on the right, and the rutting is the axis there on the left. So you can see as the break between the 2 test sections, we were at 10 million easels, and again, when this data was grabbed, there was a little over 18 million easels on these sections. One of the things I really wish we'd been able to do when we did the ID1 work, I was still trying to get my head wrapped around just the recycling process itself. We did not instrument the pavement there. I really wish we'd been able to, but NCAT gave us the opportunity to be able to do that. And so one of the things we're able to do with the strain gauges that are installed in the test sections, and these are strain gauges that are installed at the bottom of the CCPR layer, is look at the change in modulus, or excuse me, with FWD we're looking at the change in modulus. I've got some strain data in a second. But the FWD data, we can look at the change in modulus over time. So this is all normalized to the same temperature, 68-degree reference temperature, and we can look at the asphalt modulus versus date. I put these, whoops, wrong button. I put these lines on here. Hopefully you can see the trends in the data. The red line towards the top with the highest modulus, that's the section with the FDR, the 4-inch overlay with the FDR under it. And then going down, the next section is the 6-inch overlay over top of CCPR, over top of the aggregate base. And then the blue line down at the bottom is the 4-inch asphalt overlay over top of CCPR, over top of aggregate base. So it's kind of doing what we expected it to do in terms of ranking. The one with the FDR underneath, the FDR is giving a positive influence to the stiffness of the asphalt layers above, since we're measuring with the FWD. again, the ranking order is kind of what we expected. What we weren't quite sure we were expecting to see is this change in modulus over time. And what's been interesting is the two sections with the aggregate base, you can see there's a downward trend to the stiffness there. So we are seeing some internal deterioration, even though we're not seeing it at the top of the pavement surface. But that section with the FDR, if you look at the slope of that line, that slope's actually increasing. So we are seeing a positive change in stiffness of that layer. So there's curing going on in those layers. This is the strain data. Again, taking the strain data and going back and normalizing it to the same temperature, looking with respect to date. You can see that the blue line, again, that 4-inch asphalt overlay, the line is increasing, so there's more strain happening in the bottom of that layer over time. So again, we're looking, one of the things we really want to learn with these sections is how would these recycled sections deteriorate over time. And what we think is happening is that they're just going to gradually start to lose their stiffness, at least I hope gradually, lose their stiffness over time and become less resistant to the bending effects. And I think that's what we're seeing with that thinner overlay. However, 18 million easels, I've got no complaints. 18 and 20 million easels, if I were to look at our interstate system, we would cover about a quarter or so of our interstate system on a 20-year design at that level. So based on the data I've got here at NCAT, which to me is a more severe condition than we'd have in Virginia because of the temperature, I would feel really comfortable putting that type of design out on a quarter or third or so of our interstate system. Again, looking at the strain data, for the red line there, that's the section with the FDR beneath the CCPR layer. You see that's pretty much flat. And so we're not seeing an increase in strain over time. What's been interesting to me, at least, is looking at the value of that strain level, and I hope you can see those numbers. And Bud's touched a little bit on this yesterday. I'll show a couple more slides in a second on it. But if you look at those values, those strain levels are down in that neighborhood where we think this is going to be a perpetual section, or act like a perpetual section. The thing that we don't know is how do these recycled materials perform at these low strain levels? Would they crack like a normal asphalt mixture with fatigue? I'm not sure they would, but if they do, we're in that area. One of the other things I wanted to show, we also have pressure plates installed on top of the subgrade, so you can look at the reduction in pressure with that FDR layer. It's a significant reduction in pressure. We're probably looking about 3 or 4 PSI on top of the subgrade. So NCAT, luckily, they have very good subgrade material, but if we did not have very good subgrade material, this design would still work well because we've got such a reduction in pressure there. Even the sections with a thinner, the same asphalt or thicker asphalt overlay and just the aggregate base, you can see that the subgrade pressure, we're still down to 6, 7 PSI, maybe 8 PSI neighborhood, which is still pretty low. So this is where I want to get into a little bit and cover a little more what Buzz talked about yesterday. If you recall these curves that Buzz showed, there's a report on the NCAT website where they looked at, instead of defining the strain limit for perpetual performance as a single value, they looked at it in terms of a distribution. And so the distribution they came up with is this dark black line. And they're saying that any pavement that has a strain distribution to the left of that is in a perpetual section. So I colored my green blob over there because it looks good. And anything over to the right, consider bad. That, bad relatively, but bad in the fact that it may not be a perpetual section. And so I colored those in to give you an idea where our sections are. As I go through and walk through each of these lines and again try to highlight them, that's our section with the 4-inch asphalt overlay. And again, it makes sense when you compare it to the 6-inch asphalt overlay in the blue line. The 4-inch one is further to the right, so if I expect any deterioration in terms of fatigue performance, I expect that one to go before the 6-inch one would. But on the other hand, if I go and look at the green line again, that's the line with the FDR section, you can see how far it is over to the left, and it's well into the section that should be a perpetually performing section. Some of the information that I've put out on this, if we look at the cross-section of that section S12, that entire cross-section is about 80% recycled material when you count the FDR, the CCPR, and then the rapids and the asphalt overlay. So I look at it in my mind and I think, well, why couldn't we be doing the same thing on a new section of roadway? And I know I've had that conversation with a couple folks here. That's a way for us to think outside the box. It's not just rehabilitation. We can also look at new construction with this. That I'll get into here in a few minutes. So some of the results we've got from NCAT so far, as of September, 18.8 million easels. On the surface, we're not seeing any visible distresses. The ride quality has been steady, and we're seeing rutting at less than 0.3 of an inch. I borrowed Dave Tim's wording. Structural metrics show healthy sections. However, in N4, we're seeing increasing strain, so at some point we're going to see something happen in that section, just don't know when yet. So I mentioned before, we're going to be sponsoring 2 sections going forward. One of those sections is the FDR section, S12, and one of them is this N4, because we think that will be the first one that does anything. So we're going to drop section N6 for the next, N3 for the next section. We'll continue to sponsor these 2 for a third round of testing, or another 10 million easels. Again, S12, the section S12 with a 4-inch asphalt overlay, the CCPR and the FDR underneath that, we're expecting to see perpetual type performance. And as I mentioned, including the wrap content of the surface layers, that thing's got about an 80% recycled content. So maybe the asphalt layers aren't 100% or really high wrap content. They're in the, I believe, 20 or 25% wrap neighborhood. But when you look at that entire cross section, the entire cross section is about 80% recycled material. So one of the things that I really like about the work that I do with the agency, working for VDOT, is the work that I take in research. I mean, I love doing the research, but I really like to see my work get implemented. And I hope I was able to make that point yesterday in the presentation about the 962 project, although I really want to implement the work that we're doing there. Same with this. I want to see the work that we're doing taken someplace and being used. And it just so happened, my colleague Ben Bauer, some of you know him, he and I, we sit around my office sometimes, feet up on the desk, and think about stuff, usually after having a big pizza lunch on Friday. And it doesn't look like much, but we're actually sitting there brainstorming about things and kind of free thinking. And one of the things that came up to us a couple of years ago was this project that we had coming up, a big reconstruction project and lane widening project on I-64 on the eastern side of Virginia, down the Hampton Roads, actually right next to Williamsburg, if you're familiar with that area, Williamsburg, Yorktown, and so on. This project was going on, and Ben and I were thinking to ourselves, well, why on earth are we not thinking this recycling process? We've got a design, what we used on NCAT and 81, that are sort of similar. We're seeing fantastic performance. Why don't we think along these directions? And so we made a pitch to the folks. This was a design build project, and we have an alternate project delivery office. We made a pitch to them, and they bid on it. And so the project went out, and it was awarded January of last year, but the year before that, we made the pitch to them. And we thought the project would go through as a recycling alternative, and they liked what we did so much that it became the design. There was a recycling design, and that was it. So it was pretty unique for us. So again, this project down in Williamsburg, it's a big project. It's an existing 2-lane concrete roadway, and a decision was made, not by me, but by the executive level, that the 50 or so year old jointed concrete was going to be pulled up and totally reconstructed. So the sequence of construction on this work is that they will go through and add a new lane to the inside, both directions, and a full width shoulder, and then move traffic over there, and then reconstruct the existing lanes. So it's about 7.08 directional miles. When you count all the lane miles, it's about a 60 lane mile project. It carries a higher ADT than our 81 project, but if you look at the number of trucks on there, it's actually fewer trucks than what we have in the 81 section. So we feel pretty good about the design, being that it's similar to 81, and we're seeing such good performance out there that it'll take even longer to see the same traffic volume on this section. So again, scope of the project, adding a travel lane and 12-foot shoulder to the inside. The folks at the district really like the idea of doing a recycled concrete foundation for that. So the contractor has actually balled up as much recycled concrete or crushed concrete as they can find in the neighboring couple states, and they've brought that in, and they're incorporating that in an FDR process. So that's why I have in here in parentheses place like FDR. On top of that, a CCPR base will be placed, and then 4 inches of asphalt overlay will be placed on top. And again, that's for the new lane and the new shoulder to the inside, both directions. When that process is finished, traffic will be moved over, then the existing lanes will be reconstructed by removing the existing concrete, FDRing the existing foundation, CCPR base, and 4 inches of asphalt overlay on top of it. So the big thing that I did, I guess, in the pitch when Ben and I presented to our alternate project delivery office on how we really sold them was we showed them this information. The original design for this section was 8 inches of asphalt over top of 8 inches of cement-treated aggregate. And if you do a square yard cost on that, it's about $71 a square yard. We came in based on some of the data we had from some of our other projects on recycling, and the design that we came up with about $45 a square yard. And we said to them, well, you've got the same structure. If you go through and run through the SN calculation, same structural value, 36% lower cost. So their eyes really opened. We talked about environmental and all this other stuff, and they liked it. But until we told them we could save a pile of money, they really weren't quite as interested in it. So again, that's the design that went through. Our our numbers, the numbers we got back at bid were actually pretty close to our estimate. So the section that's going in is in the neighborhood of $45 a square yard. This is a picture of the plant from that site. We had a new contractor came in, and they were a larger multi-state paving operation, and they actually came in and bought the KMA to do the CCPR work, and they bought a reclaimer to do the FDR work. Again, we were lucky enough the project was big enough they were able to afford to do this type of work. So we had a test strip on the CCPR a couple weeks ago. In the background, the picture is their processed wrap stockpile. So this particular process, they're using 85% wrap and 15% screenings. And I've talked with some of our aggregate folks, and actually it's working out pretty well for them because they're having a difficult time finding something to do with the screenings, and this is a good way for them to incorporate it into this project. So again, you can see they're dumping the CCPR into the machine, dumping the wrap and screenings into the machine, processing it, and then putting it into the truck, and that's coming straight out to the paver. And this is a photograph of the work we did on the side of the road. So the design, I didn't show quite all the details. Underneath here is the cement treated layer, and then we put a 2-inch drainage layer on top of that. And then the CCPR is going on top of that. So they're all walking around on the drainage layer, and then here goes the CCPR. The CCPR is a 6-inch thick layer. They're placing it, if I remember right, almost 8 inches prior to compaction. So these are the two new lanes. Will be the new, I guess, left lane. Here will be the new shoulder. Here's a concrete barrier. You see the existing concrete over here, and then traffic is pushed over a little bit. They're running in the existing lanes and a little bit onto the rebuilt shoulder. So the traffic is running over there now. In terms of the quantities, it's a big project. The bid quantities came back at 168,000 tons of CCPR. So again, we've got 10 million tons stockpiled wrap, so we're using some of it. 168,000 tons, and about 345,000 square yards of FDR in this one project. It's a tremendous project. The big thing that really sold, again, our alternate project delivery office was the next thing, is the cost savings. We estimated more than $10 million cost savings by that design change we had for the recycled section. This work is going on right now. They're starting to do, they're doing the test sections on CCPR and FDR. FDR was supposed to have happened yesterday. I hope it went well. I wasn't there, unfortunately, but fortunately I was here. So hopefully that work is going well. We'll be constructing, I guess, in the new lanes until some point next year, and then switching over to the reconstructed lanes towards next year. Another interesting fact is that this Hampton Roads region is just booming economically and booming with population growth, and so they were really looking at widening this section of roadway. This is the main connection between Richmond, our capital, and the Hampton Roads region. And it's 2 lanes each way with that 70-some thousand vehicles per day on it. So they were looking to widen coming east towards Richmond. So this is segment 2. They're actually doing a segment 1, but there's no recycling on that part, unfortunately. We didn't get there early enough for that. So there's a segment 1. We're doing this recycling work on segment 2, which is 7.08 miles. They have let the RFP for segment 3, which is the next 8 miles adjacent to segment 2. So the next 8.2 miles coming east. And again, my assumption is, what I've heard is the recycling design is going to be used again on segment 3. So it's not an alternative, it's the design, the recycling design. So 8.2 miles with the same design, I would estimate the cost savings are probably going to be in the same neighborhoods what we've seen on segment 2. And talked with some folks on the bus yesterday. One thing I tried to highlight with our folks up on the, I guess, executive level of the agency is that cost savings on this one project has paid 2 or 3 times over all the research money we've spent on pavement recycling work. So we've made it on one project 2 or 3 time cost savings versus what we spent. So significant savings can be achieved, but I know not everybody has mega projects like this. We've just been lucky to be able to do it. So in summary, the work that we've done so far, we've seen really excellent performance on our recycled pavements, and including in high traffic conditions, again, using these kind of outside the box techniques and thinking. And we're seeing great benefit of combining these multiple recycling processes. I'm really becoming a huge fan of combining FDR and CCPR in this type of process, because I think there are tremendous benefits we've got from it. I'd be happy to address any questions if you have any. Thank you.
Questions for Brian? How are you managing traffic on each of these layers?
This project is really the ideal condition. They're going to build the entire thing in the new lanes and then switch traffic over. It's really the ideal case. When we did the 81 project, as I said, they built in these stages. they had a multi-day lane closure, and so the contractor actually came back and got the first 2 inches of asphalt on it before traffic ever saw it. And it ran on that for about 3 months until all the work was done, the entire project, and then the whole thing was overlaid all at once. And I was going out and doing measurements with that. We saw a little bit of rutting with that. I think we got up to maybe 0.2 of an inch or so. It wasn't significant, but again, carrying more than 6,000 trucks a day, I really wasn't that surprised with it. But one thing that they did on that project is they did a milling operation to smooth out, I guess, whatever happened on that 2 inches asphalt overlay before they put the final one on. And so that helped them get the great ride numbers, and I think that's why we're not seeing any rutting on it now. But yeah, for this 64 project, it's really the best scenario, because again, the whole section will be built, traffic will be moved over, and then the whole other section will be built before traffic comes back to it.
My question is, can you explain a bit more what the FDR was, what was it exactly? I'm not quite sure I understood. It looked like it was stabilized, not stabilized.
Whoops, where did I go? I think I broke it. For the design alternatives here on the FDR is cement stabilized, so it is stabilized. Then the CPR is a combination of foamed asphalt and cement. If I remember, the design was 2.3% foam and 1% cement.
So it was in-place material stabilized?
For the FDR process on the new lanes, the new left lane, the new left shoulder, it's actually imported material. They're stabilizing imported material. And that's, again, is a kind of a unique way to think about FDR. We've got another couple lane widening projects, and I've talked to our district folks, said, yes, you can make an FDR foundation out of stuff that doesn't exist yet. And they haven't quite wrapped their head around that either, but yeah, we can import.
Imported material, and then it went through with a pulverizers to inject or mix the cement.
Yes.
But it could have been done off-site.
It could have been done off-site. Yeah, it could have been done off-site. Kim?
What kind of airborne density were you getting on the CCTR layer?
I don't know on this one yet, just because again, it was a test section. When the contractor did a test section in their yard, they were meeting our 98% value of the CCPR. When we did the work on I-81, we had no issues in terms of the field density that we were checking. So we haven't seen big issues with the field density yet. I don't recall. I mean, again, they haven't done very much in the CCPR on this project yet, so I don't have really information on there yet. But I'm expecting that we've got a good foundation underneath, so I expect we should see good density values.
It seems like that the airborne seems to be a big issue when it comes to APEX that we've talked about.
We don't measure the air void content. We don't even measure the air void content. We know it's high. I mean, it's a recycled product. You get the fluff, so you know you're in the 10, 12, 13% neighborhood, but we don't worry about the air void content. All of our acceptance work is based on the in-place density and then Proctor values.
Question on the structural number calculations. I think Buzz said the FDR there had a coefficient of 0.3. Is that right?
When we have a design standard that we use, our asphalt, if you want to run through the math here, our asphalt layers we use 0.44, CCPR and CIR we use 0.35, and we use 0.25 for FDR, and our aggregate base would be a 0.12, and then normal cement treated layer would be 0.18. I know I ran through those pretty fast, but I can send you those numbers later on. I was looking at them this morning actually, but anyway, that's another story. The thinner asphalt overlay. I'd go thinner. I really fought for that when we did it, but it didn't happen. I fought to include the FDR. Luckily, that stuck because some of the conversations we had we would never do FDR also. So there was a lot of discussion about pulling that out, and we didn't. I'm glad. Buzz mentioned yesterday that section of Lee Road 159, this is one of their off-track sections at the track. At the same time, the NCAT sections were built, all the wrap that was hauled down to NCAT was hauled down from the 81 project. It was leftover wrap, so we hauled all that material down. And even after building the 3 test sections, there was enough left over. They built one of the test sections on the Lee Road piece. So they milled off the existing asphalt roadway, put in, I think it was a 5-inch CCPR layer, compactor right on top of the subgrade, and then a 3/4 inch 4.75 millimeter mix was put on top of that. And that's what's still out there and doing very well with the quarry traffic and asphalt plant traffic. So yeah, if I had to do a change with the NCAT section, I'd have gone thinner.
Brian, you mentioned that the contractor that won this I-64 project went out and they bought the Coke Central plant, they went out and they bought the reclaimer to do that kind of work. Have you found some challenges with them operating in an industry they didn't have experience in, or did they bring in folks that had that experience?
Yes and yes. Lucky for us, the 64 project is not the very first thing they've done with these processes. It's pretty close, but it's not the very first thing. But we've got some great technical folks that we require in terms of our specs to come in to help, unless the contractor has significant experience. So they've got to help coming in. But yes, there's still challenges.